This data represents the weights in grams of a random sample of 50 candies. And for part A, we're looking for the standard deviation. To get that, I'll open StatCrunch. So all of our data is in the first column. So if you scroll down, there are 50 data points. To get the standard deviation of this sample, I'll go Stat, Summary Stats, and Columns. Because our information is in var 1, I'll select that column, as well as standard deviation. That's all I need to select, so I'll click Compute. Okay, so here we have the standard deviation, and we want to round this to 2 decimal places. That's going to be 0.0, so that 6 gets rounded up to a 7, 0.07. All right. So for part B, we're asked to look at this histogram, which represents this data, and eventually we're going to want to apply the empirical rule. But you can only do this if your data is bell-shaped, if you look at the histogram. And while, if I'm looking at this, it's not like perfectly bell-shaped, I would say it's close enough, more so than, like skewed left or right. So I'm going to choose this first option, saying that, okay, this histogram is definitely bell-shaped, and therefore we can apply the empirical rule. The empirical rule tells you that if you're at the middle of your data, the mean, and you go a standard deviation away from the mean, you collect a certain percentage of the data. So I'll check this answer. Fantastic. All right. So yeah, part C is now asking for us to apply the empirical rule. They actually even tell us what the mean is. The mean of the data is 0.84, so that's like right in the middle. But they want us to determine the percentage of candies with weights between 0.7 and 0.98. The important thing to point out is, if this is the mean, the center of our data, if you add the standard deviation 2 times to this value, you get this value. Doubling this is 0.14. That added to 0.84 is 0.98. This number is 2 standard deviations below the mean. So if, again, you double this, you get 0.14. If you subtract that from this number, it gives you this number here. So essentially what this part of the question is asking us is, what percent of the data is within 2 standard deviations of the mean? Now, I'm going to put in the wrong answer only because it's going to bring up a nice graphical representation of the empirical rule. So again, we're looking for the data that is within 2 standard deviations of the middle. And it tells you that approximately, roughly 95% of the data will lie within 2 standard deviations of the mean. So the answer to this is 95%. But this graph is really nice. So here the mean is 0.84. If you add the standard deviation twice, this would be 0.98. If you subtract the standard deviation twice, this would be 0.7. And so we're talking about all of this data here. And that's 95% of the data. It also like partitions it where if you go 1 standard deviation away, if you're just talking about like this location right here, that's 34% of the data. And if you go a standard deviation in this direction, that's 34% of the data. If you add this part together, you get 68, and that's 1 standard deviation away. So this chart is really nice because these numbers tell you how much of the data in terms of the percent you would add. Well, enough about that. I know that the answer is 95%, and that's directly from the empirical rule. But now for part D, it's going to say, okay, we have the data right in front of us, and this is just an approximate value. We could actually figure out the actual exact percentage of data that lies between 0.7 and 0.98 inclusive. To figure that out, I'm going to go back to StatCrunch and examine my data. So you could scroll through this and just count every data point that is greater than or equal to 0.7 or less than or equal to 0.98 and divide by 50 to eventually arrive at your percentage. But there's a nice shortcut that we can do here. If you hover over var1, you'll see this arrow pointing down. You can sort the data as either increasing or decreasing. I'll choose that option there, the ascending. Okay, that takes my data and lists it from smallest to largest. So it makes it very easy to count all of the data points that are greater than or equal to this, but less than this. So you would start by including this first data point. You're going to include all of these, but we keep going. We're going to keep going until we get to 0.98, which is actually not even, that's not even on the data set. This is 100% of the data. 100% of the data falls between 0.7 and 0.98, and that was just by examining it. So that's the answer, 100% of the data. The point is, the empirical rule is just an approximation. It'll be reasonably close. However, for this problem, it was 100% of the data, exactly. Parts E and F are going to repeat this process. Just a slight variation on the last two questions. This says, use the empirical rule to determine the percentage of candies with weights that are more than 0.91 grams. All right, so again, entering in the wrong answer just so I can refer to this chart that's in front of me. This 0.91, how many standard deviations away from the mean is it? And it's one. It's one standard deviation above. I'm just figuring that out by taking 0.07 and I'm adding it to 0.84, and it takes me from 0.84 to 0.91. Okay, what we want to know is if we're just greater than this, we're talking about these three regions of my graph. So to figure out this percentage, I can't just simply look up here. Instead, I'm going to add this percent, and this percent here. I'm going to zoom in a little bit. It's kind of hard to see those numbers, but here's 0.91. So I'm going to take 13.5%. I'm going to do that right in a calculator, 13.5. I'll then add on this next piece, that's 2.35. And then I'm going to add on, that's really hard to see, but that's 0.15. And when I add these three percentages, that's everything that is above 0.91, and I get 16%. So I'll go back to our normal view, and I'll enter in 16%. All right, great. But again, the empirical rule is just an approximation. We can actually figure out the actual percentage by going back to StatCrunch and looking at our data. Okay, this time we want to view all of the data points that are strictly greater than 0.91. So, okay, it's not that one. We have to keep going until we get to 0.9. Well, there is no 0.91, but it starts here. So we have this one and everything above it. So that's, 1, 2, 3, 4, 5, 6, 7, 8, 9, a total of 10 data points. These 10 data points are greater than 0.91. So what I'm going to do is take 10 in my calculator and divide it by 50, because there's a total of 50 data points, and I get 0.2. To change it to a percentage, I'll multiply by 100%, and I get 20%. All right, so the idea behind this question is you can think of the empirical rule as a shortcut if your data is bell-shaped. You can always, if you have a data set, figure these values out exactly, but it's just easier to say, oh, well, roughly this will be 95% of the data. For part E, okay, well, this will be roughly 16% of the data.